Hello, thanks everyone for joining today's demo. This is about deploying OpenShift without the internal load balancer, and we will use an external load balancer that also has a BGP in the infrastructure for routing the control plane traffic. So to start, I would like to present the network topology that we will use in the demo. Um, So this is based on spinal leaf, and you can see that we have three networks for each leaf. We have three leaves. Um, we have rack 1, where the OpenShift cluster is deployed right now. In the future, we will have the OpenShift cluster distributed over the three leaves, but this is still work in progress. So for now, everything is in the same leaf. We also have rack 2 and rack 3. Uh, each of the racks have a load balancer that we deployed, and we will have a look in details on what is this. Um, and yes, so this is on the rack 1. You can see that we already deployed the cluster. We have the OpenShift masters and the three workers. We have the load balancer that we deployed. And again, there is the same load balancer in rack 2 and rack 3. And then we have a VM for hosting the router um, in on each of the leaves. It has BGP running and ready to pair, and we will also have a look at how it works. To reach that network, we connect through the spine. There is a floating IP, and we use a tunneling through the spine. In the spine, there is a VM for the router, and we use that VM to connect through all of this. Okay, so now I'm going to share my terminal. All right, so there is a bunch of windows here. Um, we have the on the top left, we have one of the master nodes, master 0. We will have a look later at this. And then we have a terminal for the client. So that's my laptop. That's where we will run a few commands later. Um, and then we have the virtual machine that is used for the router in the rack 1, so the first leaf. We have the terminal for the, the router in the spine. Um, and then we have three terminals for each load balancers, so one in rack 1 and two in the other racks. And then we have two terminals for the OpenShift workers. So that will be for the final demo. So let's start with the three load balancers. Um, so each of them has a VIP, so has two VIPs actually, one for API and one for ingress. If you look at uh, the VIPs, they are set up on the loopback device. So 100.250, that's ingress, and 240, it's API. We have FRR running. So FRR is configured to peer with the router within the leaf. And if you look at uh, the leaf router, it has the route to reach the VIPs through the IP of the load balancer. So if you want, we can do something like watch IP air, and remove the VIP from the load balancer, and you will see that the route to reach the lo- the VIP will be removed. We can also do the same on the spine. So the spine of obviously has BGP peering with way more um, BGP hosts, so the three load balancers, which is why for each VIP you will see three hops. Um, so now, if you look at my terminal on the top right, I'm going to delete the VIP, and on the the rack 1 router, you will see that the VIP will be removed to reach the uh, to reach the API, and on in the spine you will see that you will have only two available hosts to reach the API VIP. And this is it. So you see that BGP is working well. So we can re-add the VIP in place. Okay, and that's back to normal. Okay, so that's for BGP. We already had a demo the last time about how did we configure, how did the load balancing works and the failover. So I'm not going to demonstrate that again, and I suggest you to look at the previous demo for that. So I can close this terminal. Okay, now let's have a look at the load balancer. I want to show you the HA proxy configuration. So um, in OpenShift, when running on OpenStack, we don't support fixed IPs yet, which means that we don't know in advance the IP addresses of the OpenShift clusters. This is something that we will be working on in the future, but right now it's not supported. So for the external load balancer, we had to configure the backends for all the IP addresses available in the subnet that is used for the OpenShift cluster machines. So to make it, I guess, easier and faster, we created a subnet with a small allocation pool with only a few IPs of the subnet, not all the /24. So um, we have a few front ends. We have the one for the API, OpenShift API, and then we have two front ends for the ingress, HTTP and HTTPS, and then we have the machine config server as well. Um, and it's using the proper health checks URL to check whether the service is up or not. And based on that, it will load balance the traffic using round robin to those nodes. Okay, so the last thing I want to show you on the load balancer, it's the IP routing rules. So because we do install the VIPs on those nodes, and the VIPs are not part of the subnet of the machine, we have to force the VIP traffic to go back through the gateway, which is 10.1, the leaf router. And if we don't do that, the other machines within the same network won't be able to reach uh, won't be able to establish TCP connections like reaching the machine config server, or doing API calls to OpenShift uh, by using the VIPs. So yeah, so that's something that we did on the machine, and on some other external load balancers like F5 or Cisco. You can create routing policies that does exactly the same thing. Okay, so now let's talk about the OpenShift cluster. The first thing I would like to show you is the install config. So when using an external load balancer, it's pretty simple so far. Uh, the um, the only thing that I would like to mention is, well, actually two things. The first one is, as you can see in the platform, we don't specify the VIPs, and we don't need to uh, because um, because we use the DNS to resolve where the VIPs will the IP address of the VIPs through the DNS. So we don't mention the IP address anymore. And the second thing I want to highlight is that in the machine network, we have to specify the subnets um, that will reach the OpenShift cluster, not only the masters, but also the workers. This is for the security groups, and so the services can be reachable from those subnets. So for example, the three first subnets, the first three subnets are the three leaves that we have, and the last one is the spine network that is used when the other load balancers in the racks try to reach uh, the cluster which is in the first leaf. The traffic is going back through the spine, and obviously the IP address is seen as this subnet. So we have to authorize this subnet to reach this the control plane. Um, Obviously, to save some time, I deployed the cluster. You can have a look. Well, even if I did before with the screenshot, but uh, you can see that we have the three masters, the three workers, the three load balancers, and the three routers on each leaf, and the spine router as well. Um, One thing I would like to show you is that because we didn't specify the VIPs in the install config, um, we don't see it in the platform status. So if you do OCGET infrastructure, usually we'll see the ingress and the API internal VIPs. In this scenario with external LB, you don't see it anymore. Um, On the master node, I would like to show you that we don't have anymore the services for on-prem load balancer. So we used to have HA proxy, we used to have Keeper LiveD, Core DNS. We don't have them anymore. Like I said, we externalized the load balancer to be on a VM that we manage. So OpenShift doesn't deal with that anymore. Okay, so now I would like to do a demo of the ingress services. And to do that, I'm going to clean up my screen a little bit. Okay, so um, I'm creating a new project, a new app. Okay, so we have the new app, and I can test if the new app is working. Okay, so as you can see, the ingress traffic went through one of the two workers that host the ingress router, um, and the other worker is at the bottom. So if I do multiple curls, you will see that it's going through both of the workers. So it's actually load balanced. Um, yeah. So and now what I want to show you is the failover. So if um, if you look at the TCP dump here, you can see that the IP address 10.2, it's because the traffic is coming from load balancer 1. But if you look at now on the bottom, the latest request comes from the spine because the traffic went through load balancer 2 or load balancer 3. Oh, and now the last request went through the load balancer 1. So what I want to show you is kind of like HA, where I'm going to shut down uh, the VIPs for uh, the ingress on load balancer 3 and load balancer 2. So in theory, the spine uh, should only see one host for the ingress VIP, which is the load balancer 1. Good. Okay, so now if I do the curl, I should only see the request going through load balancer 1, which is the case. Now, if I recreate the VIPs, it's going through all the load balancer and I can see all the routes. So in this POC and in this demo, um, we we don't demonstrate when the VIP is available, but the service is not reachable between the load balancer and the OpenShift node. So if the VIP is up on the load balancer, but the uh, the ingress is not reachable from the load balancer, we will have some issues, and that's something we will have to investigate and provide some solution for it, especially when using uh, the external load balancers. So otherwise, that's it for the demo, and I hope you liked it. And stay tuned for the next demos. And don't forget to ask me any questions or drop some feedback. Thanks for watching, and see you next time.